This is number 4 on curve sketching, non-calculator. Let f be the function defined by k square root of x minus natural log of x. Again, domain is to the right of 0. K is a positive constant. Find f prime and f double prime. Something important here is to make sure that we understand k. We'll treat k the same way that we would a 3 or 4, just a number in front of a variable. Okay. So let's get our function ready for us to find f prime. We can rewrite the k root x as kx to the 1/2 minus natural log of x. We can go through power rule for the first term. Second term, we can use natural log rule. So we can go through power rule, bring down the 1/2, subtract 1 from the exponent. The k just hangs out in front, like as if it was a 3x or a 4x. It will just stay attached to our derivative. Natural log of x's derivative is 1 over x. I'm going to clean that up a little bit, make it x to the -1 to get it ready for the next stage, so I can move down to the second derivative function. So again, I can apply power rule for both these terms, bring down the -1/2, subtract 1 from the exponent. -1/2 times 1/2 is -1/4. -1/2 minus 1, same thing as -1/2 minus 2 over 2 is -3 over 2. And then we go through power rule there, so negative times negative is positive 1x to the -2. So we have our first derivative function cleaned up, and the second derivative function cleaned up here. Okay, part B. For what value of constant k does our function f have a critical point at x equals 1? Okay, so critical point is where f prime is equal to 0. So let's establish that truth there. So we want to know, when is f prime equal to 0, but specifically when x is equal to 1. So let's just set, we have f prime already. Let's go ahead and set f prime equal to 0. Let's go ahead and replace x with 1 and then solve for k. So I have k over 2 minus 1 over 1. So k over 2 is equal minus 1 over 1. I can bring that 1 over to the other side, cross multiply. I get k equals 2. Okay, so we have our k value. For this value of k, determine whether our function is a relative min, a relative max, or neither at x equals 1. So let's place 2 back into f prime. But what we're going to do is we're going to apply the second derivative test, because if f prime of 1 is equal to 0, which we already established here. Okay, let me make sure I highlight that. It's f prime of 1. If f prime of 1 is equal to 0, then f double prime of 1 will give us information whether this point is a relative max or relative min. Okay, so I'm going to plug 1 into the second derivative function, and we already know what the k value is. So I'll replace k with 2, replace x with 1. I get -2 over 4 plus 1 over 1, which is 1/2. -1/2 plus 1 is 1/2. So if my second derivative value is 1/2, that means that this part of the graph must be part of a concave up graph. If the curve is part of a concave up graph, that means the graph will look something like this. And if my graph is part of a concave up graph, and I know that my slope is 0, then using those two information, I know that this must be a relative minimum. Okay? By the second derivative test. Part C, for a certain value of constant k, the graph of f has a point of inflection. Find this value of k. Okay, so we know point of inflection is going to exist at on the x-axis. So we know the x-axis has a y value of 0. Okay, and we also know that there must be a point of inflection, which means that f double prime must be equal to 0. And then we also know f of x is equal to 0, simply knowing that the ordered pair has to sit on the x-axis. So we have two pieces of information that we can use to start us off. We can set f double prime equal to 0. Okay. And then we can clean up and see how far we can get. Cross multiply, solve for k, I get 4x to the 3/2 over x squared. Clean that up, I get 4 over x to the 1/2, which is 4 over root x. We also know that the x-intercept location must mean that the function must be equal to 0, so I can set f of x equal to 0 and clean this up and see how far I can get if I can solve for k as well. So I can set both, I can start off with both properties and work my way down to k equals. And if I can get both equations to be, my results to be k equals, then I can set the resulting expressions equal to each other, and then that will help me solve for x. If I can solve for x, then I can turn around and solve for k. So I have 4 over root x is equal to natural log of x over root x. Cross multiply, the root x cancels out. I'm left with natural log of x equal to 4. I can exponentiate both sides to get this x away from this natural log. So e to the natural log of x, same thing as just x equals e to the 4th. And now that I have x being e to the 4th, I can turn around and find the k value, plug into either k value. I get k is equal to 4 over e to the 4th, and that is our answer.